Hey everyone! In this video we're going to discuss some basic algebraic skills needed to work with quadratic equations. The first of these is combining like terms. In this expression 5x plus 3x squared minus 8x plus 7, we would look for terms that have the same variables and the same exponents, and that's what we mean by like terms. Alright, so to distinguish the terms, you look for the plus or minus signs, and then the terms would be on either side of those. Alright, so we have four terms. We have 5x, 3x squared. If there is a minus sign, it counts as part of the term, so that's a negative 8x, and then 7. Alright, so to combine the like terms, I would look for the same variables and the same exponents. So, for example, the 5x and the negative 8x both have an x with an exponent of 1. So those are like terms. Okay? So now I want to combine those. And I'm using the commutative property to kind of pull those out of order. Alright, so I can add this in any order that I like. Alright. Now it's the distributive property that says that I can take out an x. Okay, so that's like the distributive property in reverse. And then that's negative 3x. Alright, so basically when you're combining like terms, you combine the coefficients, the 5 and the negative 8. Okay, that's negative 3. And then the variable and the exponent stay the same. So now we have 3x squared, a positive 7, and a negative 3x. Alright, so I'll rewrite that, and we usually write that with the highest exponents first. So that would be a 3x squared, then minus 3x, and then plus 7. Alright, now none of these are like terms since I have x squared, x, and then just a number. So that's the final answer. Okay, next let's talk about multiplying algebraic expressions. So the first one here, 3x times 4x minus 11. I'm going to use the distributive property to multiply. So I need to do 3x times 4x and 3x times negative 11. Alright, so 3x times 4x is 12x squared, so you do 3 times 4 and x times x. And then 3x times negative 11 is negative 33x. Negative x times x plus 6, so same idea, you're distributing a negative x, so negative x times x is negative x squared. Negative x times 6 is minus 6x. Alright, what about multiplying two binomials together, two things with two terms? Alright. So 8 minus x times x plus 3, we're going to do the same thing. We need to distribute. Let me show you the long way of doing this, and then you may remember a shortcut as well. Right, so the long way I think is nice because it shows that this is based on the distributive property, kind of explains why the shortcut works. Okay, so first thing we would do is distribute the x minus 8 to both the x and the 3. So we would have x minus 8 times x, and then x minus 8 times 3. Alright, now I can use the distributive property again, this time from the right, so I can do x times x and x times negative 8, and that's x squared minus 8x. And then over here I can do 3 times x and 3 times negative 8, so that's 3x minus 24. And then at the end I would combine like terms, so x squared, then negative 8x plus 3x is negative 5x. Alright, and then minus 24. Alright, so you may remember the shortcut. This one's a little more familiar. It's FOIL. Right, and that's an acronym. It stands for first, outer, inner, last. So that tells you an order of terms to multiply. So let me get rid of this middle step here. Alright, and we'll try it using this method and then we'll compare. Okay, so FOIL says multiply the first terms first, so x times x, that's x squared. Right? Then the outer terms, so that's x times 3, so that's plus 3x. Then the inner terms, negative 8 times x, that's negative 8x. And then the last terms, negative 8 times positive 3 is negative 24. Alright, so notice when we do this, we get the same 4 terms as when we used the distributive property. Alright, the only difference here is just that the order of the middle terms are switched, and that just sort of happened by chance, just based on the way that I distributed, but there's nothing wrong with having those in a different order, because the next thing I'm going to do is combine the 3x and the negative 8x to make negative 5x anyway. So we get the same answer. Alright, so FOIL is just an acronym that helps you remember how to distribute in a very specific case when you're multiplying two binomials. Alright, so let's talk about what that is, a binomial. Okay, binomials are algebraic expressions that have two terms. Okay, so bi meaning two, and then nomial is like the short for name. Alright, so like a two-named or a two-termed polynomial. Alright, so examples would be x plus 3, x minus 4. We could have x squared plus 6x. We could have x cubed minus x to the 5th. Okay, so those are all two-termed things. Now notice something like 3x plus 2x. It looks like a binomial, but it's actually not. We can combine these, they're like terms. So this is 5x, and that's actually a monomial, a one-termed polynomial. Right, so there's kind of the unstated assumption that we combine like terms before we look at whether or not this is a monomial or a binomial, etc. And then a trinomial, you may have the hang of this now. A trinomial is a three-termed polynomial. Right, so for example, x squared plus 4x plus 3. Alright, let's try one more example. Alright, how do we simplify or multiply x plus 3 squared? Alright, well here's one thing that this is not. This is not just x squared plus 3 squared. Right, so exponents do not distribute, and this is something we looked at when we looked at properties of the real number system, and we had a question that asked, do exponents distribute like that? All right, well here's the algebraic way to find the true answer to this. Okay. We need to recall the meaning of exponents. Right, so squared means whatever the base is used as a factor 2 times. So like if I had 4 squared, then 4 is the base of that exponent, and the 2 tells me to use it as a factor twice to multiply it times itself. So x plus 3 squared just means x plus 3 times x plus 3. Oops, sorry. Alright, and then we would multiply using the distributive property or FOIL again. Okay, so using FOIL, x times x is x squared. Then the outer terms, x times 3 is 3x. Inner terms, 3 times 3 is also 3x. And last terms, 3 times 3 is 9. So this is x squared plus 3x plus 3x is 6x plus 9. Alright, so notice that it's similar to what we get if we distribute the exponents, but what we were missing in that case was this middle term, okay, the 6x. So what are quadratic equations? We've talked about linear equations, ones that look like y equals mx plus b, or in general just anything with just a single x as a variable, like 3x equals 12. We would say that that's a linear equation as well. Alright, so a quadratic equation is any equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a is not 0. Right? And this is called standard form. So here's an example. Okay, 3x squared plus square root of 2x plus 1/2 equals 0. All right, so 3, square root of 2, and 1/2 are all real numbers. And 3 is not 0, so this is a quadratic equation. Okay. Now it doesn't always have to appear in this form. So for instance, if I rearranged this and let's say maybe I subtracted the 1/2 and moved it to the other side, that's still a quadratic equation, it's just not in what we consider to be standard form. So how do you tell if something is quadratic? First of all, look for a highest exponent of 2. So if I had like 3x cubed or something, that's not quadratic. And then look for a single variable like an x. If I change this and equals, negative 1/2 y or something like that, or negative 1/2 y squared, then that's not quadratic. Now, the coefficients can be things like square root 2, negative 1/2, but for this course we'll mostly be working with quadratic equations that have integers or maybe just fractions. So we'll stay away from things that have coefficients like the square root of 2. Alright, so let's practice with standard form. Write each equation in standard form and identify A, B, and C. Okay, so standard form, you're going to want to get used to what this is. Okay, so standard form, you should right away think ax squared plus bx plus c equals 0. And we want to just move the terms around to try to get it to look like that. Alright, so in part A, so first of all, I need to set this equal to 0. I need to have all of the terms on the same side. So I'm going to subtract 3x from both sides. Alright, now on the left, I'm going to write these terms in descending order, meaning starting with the one with the highest exponent and ending with the one with the lowest exponent. So I would have 9x squared first, then minus 3x, and then plus 7. And on the right, 3x minus 3x equals 0. Alright, so now what are a, b, and c? Well, a is the coefficient with x squared, so a is 9. B is the coefficient with x, and if there is a negative sign, it does count as part of that, that coefficient. So b in this case is negative 3. And then c is the constant at the end here, the term without the x, so c is 7. Alright, b you can practice on your own if you like, that's very similar. Let's look at part C here. Alright, so same thing, I want to move all the terms to the same side. Now I could subtract either one, the 5x squared and move it to the right, or the 25 and move it to the left. And typically we would move the terms so that the x squared term ends up with a positive coefficient. So usually I would subtract the 25 instead of the 5x squared. And then we end up with 5x squared minus 25 equals 0. Alright, so now a is 5. And then what does b equal? Well, b is the coefficient with the x term, and in this case there is no x term, so that means that b would be a 0. Alright, so any missing terms that you don't see have coefficients of 0. And then it's c that's the negative 25. Alright, part D. Alright, how do I write that in standard form? Well, in this case, there's actually some multiplication that needs to be done. So standard form doesn't have, an exponent on this whole parentheses or anything like that. So what we need to do is use order of operations to multiply and simplify that left side of the equation. All right, so the first thing I'm going to do, order of operations, parentheses, okay, x minus 4. I can't do the part in parentheses since those are not like terms. So then we move on to exponents. And I can square this algebraically, so I'm going to use FOIL to do x minus 4 times x minus 4. Alright, so that's x squared, and then the outer terms, x times negative 4 is negative 4x. Inner terms, negative 4 times x is negative 4x. And then last terms, negative 4 times negative 4 is positive 16. And then combine the like terms in the middle, x squared. Okay, and then minus 4x, and minus 4x is negative 8x plus 16. Alright, so that's x minus 4 squared, and now I have that times 3 equals negative 8. Alright, so next in order of operations are multiplication and division in order from left to right. So I do have a multiplication to do. If you see a number outside of a parentheses, that means that there is some distributing to do. That's a type of multiplication. So I'm going to distribute 3 to the parentheses and get 3x squared minus 24x plus 48 equals negative 8. And then finally I need to move the negative 8 to get this equal to 0. So add 8 to both sides, and we get 3x squared minus 24x plus 56 equals 0, and that's standard form. Alright, so A, B, and C, well, A is 3, B is negative 24, and C is 56. Alright, we'll stop there, and in the next video we'll pick up with looking at standard form in comparison to vertex form, which is another way to write a quadratic equation. It looks a lot like part D, this type of equation that we just looked at.